Okay, so this is how I remade the taxicab problem. I kind of redrew out the coordinates and then labeled the points. The T's for the taxicab station, and then A, B, and C are the different points that we had to get to. The blue numbers are the total number of paths to that point that only go east and south, and that never pass that point. So, for example, all of the edges, it's only going to take one path to get there. So from T to this point here, there's only one path. From T to this next point, it's only one. T to the next one, so all the edges should only be a single path. What I was talking about in my description was that you can use the point, how many paths are to the point directly above it, as well as directly to the left of it to add together to create the total number of paths. So for example, there's only one path to get to here. There's only one path to get to here. So that one path plus this one path would equal 2 paths, which I got there. So it's 1 plus 1. And they talked about it on the analytic as well. They showed the exact same point and how they created the 2 paths. So I can jump down anywhere on the grid. So here, how about this 35? So I found out there were 20 paths to get to this point. There's 15 paths to get to this one. Those two can add together to kind of make like a backwards L shape to add to 35 different paths. And you'll start to realize that this does connect to Pascal's triangle where the edges are all going to be 1. And if you look at the diagonals, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, the total number of paths do relate to the numbers in Pascal's triangle, just kind of on the diagonal. But that's how I was adding them together to create the total number of paths without actually having to draw them out. You just total up the number of paths directly to the left of it, the block there, and the block directly above it. So 3 plus 3 equals 6. And then 6 plus 4 equals 10. 10 plus 5 is 15. 15 plus 6 is 21. And that's how I found the total number of paths. So I hope this helps explain. I can see it in my head, so I hope you guys can understand too.